girls. What you're about to see is out of this world. Step right up now, don't be shy, because we're about to show you how cars can fly.
Who dares to fight with the icon of his day, and she finds her own miracle on the way. I said, hey now, life's a joy. You gotta try your best and give your all, and when the facts don't fit the theory, change the facts again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. It's a beautiful day.
5, 4, 3, 2, 1. Silence. Hey, it's a beautiful day, that's for sure. Again, I got my new countdown. That is so great. The music from Einstein Wrong, The Miracle Year, the documentary I spent 8 years of my life doing, but it has one of the best comments we get from about the movie is it has amazing music, and that was the Miracle. Yes, The Miracle Day, and that was written by Michael Ruggieri, and The Miracle Year, it's called. I'm sorry. Michael Ruggieri, lyrics, and the singing by Kayla, and great music. I haven't seen EinsteinWrong.com. Go to EinsteinWrong.com, The Miracle Year. Great music. And of course, you have reached Saturday Science Chats. Today we have a big subject, gravities. We're going to have one day on this. I'm sure we're going to have many more days on it. But you, again, have reached Saturday Science Chats, sponsored by the John Chappell Natural Philosophy Society and Dissident Science. Hello. This is David D. Hilster, and you are here again every Saturday. We are here, and today we got a great subject, and we're going to talk about that. But of course, as normal, I have slides to show us, to let us move forward here. Sharing my screen, and hopefully we'll get this right today. Last time I had all kinds of slides from the week before, but I've gone through them. But again, if you tuned in for What is Gravity, you're in for a treat. We've got a special guest with us today, and we're going to be watching some of his work on gravity. Actually talks about 3 types, and so don't go away. It's really going to be a great day. So again, we are Saturday Night Live, Saturday Science Chats by John Chappell, Natural Philosophy Side, and the Dissident Science channel. I want to welcome all the subscribers from both of those channels. I appreciate it. You're not going to find anything like this on the internet anywhere. We do allow and talk about critical thinkers, ideas, new models of the universe, our criticisms of current models, and proposals for new models, for example, for gravity. We're going to be talking about those today, so you don't want to go away. And of course, before we start, I did think about this. I saw a movie called, I think, The Radium Girls, because we're all COVIDed in, and we watch. There's a lot of great films. I tell you, there are just so many great films out there. The Professor and the Madman, you got to see that. One's about the writing of the dictionary, the English dictionary. But I saw the one on Radium, and it was really great, and it really got me thinking about how people have to fight the system, because they had to fight the system in a very traumatic way. And I really want to thank everybody who's wandered on here, who have been doing this for decades, who have been trying to find truth in science, trying to find new ideas and new models. Listen, it isn't easy. I know we argue amongst ourselves on what gravity really is. But really, folks, you got to remember, this is a brave place to be. We should have millions of followers on our YouTube channels. We don't. Why? Because it's easy to follow the flow and what everybody tells you and not think, and then have to think, oh my gosh, is everything they're telling us in school not right? Well, if you believe that it is, I would urge you greatly to take the time and take a look at it for yourself. We're not here to tell you how to think. We're not here to tell you the answers, but we're here to try to get you to be critical thinkers. But again, I want to thank each and every one of you, the subscribers to my Dissident Science channel, the subscribers to the CNPS channel. All the people are here for Saturday mornings. We've been doing this since 2008, believe it or not. Started on a platform called DimDim. No one's ever heard of it, and it actually saved the files in Flash, and we've lost some of it because we can't even encode them. But we've been around a while. People have been around a while, talking here on Saturday mornings from people around the world, and people in our organization, people I've met since the early 1990s when the NPA and the CNPS started. So again, I just really want us all to sort of step back and remember, it's a brave place to be here. This is something that everybody needs to know, that what we hear from mainstream science, when you really look at this stuff, it isn't exactly what you think. And I want to, again, thank each and every one of you for being here and your support. Of course, the mission of our organization is to be an organization that, above all, promotes critical thinking without malice. And that's about anything in science, especially physics and cosmology, mathematics. To be an organization that supports, publishes, and promotes serious scientific work outside mainstream science, to provide a forum for open debate about modern topics in physics, cosmology, philosophy, and mathematics, and to provide a forum for presenting serious papers and theories without fear of censorship. And of course, we are run entirely by its members in our paid membership. And if they don't like who we are as leaders, they can get rid of us. That was a very important thing we learned. That's why we started out as the MPA and ended up as the CNPS, because we learned our lesson the hard way. How to participate? Of course, you can sign up on our website, naturalphilosophy.org. Consider becoming a member. We'll talk a little bit more about that. Participate in our community discussions on our website, open to all. You just need to register and post news and happenings about us on social media, because that's where things are happening for sure. So our websites, the community website is naturalphilosophy.org. It is a new website that we just got from Buddy Boss, and we're really happy to have that. I think it's working really, really well. And we have also our Science Woke magazine. So if you're really new to this is the first time you've seen this channel, because people watch these recordings, check us out. If you don't know that there's problems in mainstream science, go there. And we're not talking about, we're not, aliens and talking about moon landings, true or not. That's not us. We're really focusing on physics and cosmology. We've got bigger problems to worry about than those kinds of things. And you can check out sciencewoke.org, and it's like it's an online magazine. It's an online magazine, very well organized. You'll find out the movers and shakers in the critical thinking world. You can find out really great articles written by some really great people. There are a lot of them. One of my favorite is Harry Ricker. Hey, check out he's a great writer. He's written some really great articles there. Check it out. And then also we have our Wikipedia, which is over 10,000 pages of places you can publish things like the best Wikipedia entry for expansion tectonics, written by Dr. James Maxlow. You're not going to find that on Wikipedia because it is a consensus place. They don't like any ideas that aren't all agreed upon, and that's kind of dumb, because that's where everything changes, right? That's where change in science happens. Of course, we have our university, and that's not open yet, even though we have opened it. We don't have our courses. We're working on that this year, so you want to pay attention and look out for that. Also, our memberships and donations, go to our website. You just go click on members, and then there's a pay membership donate. There's a button there. You can either donate. You can see there's a donate, or you can go and again, look at our memberships. We have monthly from $5 to $50. We have are yearly from $50 to $500, and we have new memberships. A new member who's been around a while, actually has 13 abstracts in their database, and finally got him hooked up, is Joseph Levy. He's an etherist. See, there you go. Most people in the critical thinking world are etherists. I'm not, but most people are. But he's there, and he just became a member on our new website. He's been around a while, but he said, "Dave, my picture's not there, my stuff is not hooked up," and he's right. So if you've registered and you haven't got yourself hooked up to our main database, there is a World Science Database number which we put in there, and all of a sudden your abstracts and books appear. So we want to check out Joseph Levy's work, and I want to thank him for becoming a member. And of course, our patrons, I want to thank them. Dr. Cynthia Whitney, our chief CMPS chief scientist, got a degree in relativity from MIT, and of course she found out in the very first job that special relativity doesn't work, isn't it? But of course we're told it does. But hey, when you have to go in the real world and actually apply it and it doesn't work, then you can't pretend it doesn't work, that it works, like the theoreticians. I want to thank Nick Percival. He's going to be speaking in a few weeks. He's made a very generous donation to us. It's greatly appreciated. All these donations are appreciated. Duncan Shaw, an anonymous donor, my father, Kurt Renshaw, other people have donated. You can donate. We do need the money. We have our monthly and annual expenses to keep these things going. So very, very important. Some news. I always like to check on some news in here. In November of 2020, I put down the idea, because if you don't know, I'm a computer scientist. I've been programming since 1978. A lot of people, I'm still young in our group, but a lot of people are the younger people, like, oh my God, they have computers in 1978. Hey, my dad worked on the Univac computer in the early 60s, late 50s, early 60s. So there you go. But anyways, I put on the Google Earth. Google Earth is that 3D model where you can zoom in all over the Earth. Well, that's open source software. And I said, hey, we're a group of scientists and we're looking to fork this. That means make a new branch of this software, which is free, and try to make it so that the Earth's radius changes. And nobody said anything. Silence and silence for a long time, until 11 hours ago. Well, it's probably a little more than that now. But he says, I've spent a lot of time in this part of the code, and the Earth's radius is likely a constant in the code. Well, that makes sense. OpenGE does not have time-enabled databases, but that's okay. That's all right. We could have to modify the database and put in another column for the time at which you are plotting this information. So I asked some questions and he answered them. Is it possible? Yes. Is it hard? Also yes. Can the overlay be modified to include time? Yes. The overlay already has a time for imagery, so it already has that, I guess. Can continents be overlays as well? Because we wanted to have the shapes grow with it. He said you can store the shapes of continents as a vector layer. There you go. Vector layer means can be drawn, and so when we make it bigger, it's easy to expand those. So I said thank you for the response, but you can check out our website, our website, naturalphilosophy.org, and check out GitHub and find out what's going on there. Here's some of the discussions going on. Zach's talking about a field is nothing more than a mathematical description and quantization of being. To understand blah, blah, etc., join in. It's really great. We have active members. There's Joseph, who just became not only a member, but also a paying member, which helps us out. We're up to 77. We have hundreds of members worldwide. They're just starting to come back and find our new website. So please get involved, and there's great discussions going on. And on YouTube, Ray Fleming has Doing Fusion at Home. Oh my gosh. Yeah, if you want to check out Ray's YouTube channel, since we've been talking about it, he just started it. He's up over 100 subscribers in our world. That's a lot, folks. Yeah, we're not like the Electric Universe, which has been around for 2008, and they've got, almost 200,000 subscribers. I only have 3,500, but my subscribers are greatly appreciated and growing as well. But check out his YouTube video on that. That's pretty amazing. Doing Fusion houses. Be careful. Whoops, what am I doing? I'm playing it. I've got to make sure we go to the next one here. My father just came out with one called On the Laws of Nature. He and I couldn't find any. There you go. So yeah, the laws of nature, are they man-made, or do they really exist? Does the speed of light really exist, or is that a law? Are there laws of nature, or do we come up with those laws ourselves? Well, that's what he said. So coming bumper. So what's coming? on this channel before we get into our talk? Well, let's see. Hey, I'm your host. I play the bumper. There we go. We talked with Dr. Alexander Unsker. It was really great. If you didn't see that, check that out. That was recorded last week. And he's the author of The Higgs Fake, Einstein's Lost Keys, Bankrupting Physics. If you haven't read those books, you should, especially The Higgs Fake, because if you believe that particle physics is good and all the particles they're finding are true, if you read about how they do it, you will see that your belief in really what's going on there will be destroyed, and rightly so, because we're spending billions of dollars to do bad science. So check him out. And coming next week, I am looking forward to this because we were supposed to be this week, but I'm sorry if you were trying to tune in for Jack this week and the announcement. Yeah, we put it out, but he got COVID. So he is recovering well. He's recorded a good video, which we're going to play ahead of time, his presentation. And symmetry math, wow. I can only say wow. And I'm a mathematician, yes. I've got a Bachelor of Science in Mathematics from the Ohio State University. And I saw his stuff, and it is super intriguing. Let me put it this way. He agrees. I completely agree with him. There are no negative numbers. What? Come on, can't be that way. And also we have coming up Nick Percival. And again, I want to thank Nick for his generous donation, but he also donates his amazing brain on thinking about time and physics of the last 50 years. He's from Harvard, and he is an amazing mind. I've had him on several times. He jumps on. I don't know if he's here. If you are here, it's great to have him talk. We're going to have him give a talk on February 13th. So those are coming up. And of course, we have Stephen Bryant, Disruptive, Rewriting the Rules of Physics. You know, the demise of relativity, that kind of thing. Really great communicator, great mind, really a modern super guy, lives in the San Francisco area. But he is on board to coming on and talking about his book. If you haven't checked it out, you can get it on YouTube. So, YouTube. Boy, I'm like, I don't know, folks. I mean, I need to get up in the morning and jog around or something so I talk correctly. But no, that's on Amazon. So, you can get his book on Amazon. Check that out. And of course, as Alexander Unsker says, a critical thinker, physicist, and author and researcher, keep on working on your passion. We are here to support you. We're not here to agree with you. We're not here to validate you. What we're here to do is to get the word out about what you're doing. And we're not the judges anyways. You know, getting Alexander Unsker to agree that your theory is right, I'm sorry, it doesn't matter if he does think that, or if he thinks it's wrong. Doesn't matter, because who's the judge of this is mankind, humankind, to put it more politically correct. So just keep working on your passion. So gravity, what is it? That's what our topic is today. And of course, we'll play today's bumper. Gravity. Of course, that's a big question. And today we have a very special guest with us. He is in the green room, thank goodness, because I have guests come on the show all the time from around the world. And I am announcing them, talking about them, and they don't show up to the green room. But you know guests. I mean, he wanted a limo. He wanted, VIP service. Let's say, hey, we're on a shoestring budget. But no. Really, Dr. Raymond Gallucci, he's a nuclear engineer, researcher, and author. Dr. Raymond is an American nuclear engineer who contributes papers regularly to the CMPS proceedings, attending their annual conferences. Gallucci believes black holes, the Big Bang, and many other current popular theories in cosmology should be incorrect. His specialty is to investigate dissidence theories and perform simple mathematics to ascertain if they are at least plausible. Gallucci acknowledges the late Dr. Paul Marmet's work and that of Stephen Crothers for first spurring his interest, he says my interest, in dissident area. And I loved Ray Gallucci. And guess what, folks? He has a book out of his famous what I call him viability studies, I call them, but he basically goes in as, is this possible? Is there something wrong here? So he's sort of an engineer. He's a really, really, really rare breed. Most people have their own theories. I didn't have one for a long time, a long model. I mean, not a theory, a model. I didn't have for a long time. I didn't want one, but my dad did something and that happened, that changed that. So I always would come on air and say, hey, I'm a person without a theory or model, but we have one we think is a good model. But I also admire a lot of other models, as does Raymond. And he has put together a book of 44 papers. So I think it's over almost 300 pages. It's available for a very, very cheap price. Raymond, what are you doing? I'm sure he was wanting to become a millionaire with his book. I'm joking, obviously, but you want to check it out. It says, if you are one who worships at the altar of Einstein's relativity, Big Bang, cosmology, etc., then this book will not be of interest. I love it. However, if you are one who questions some of the mainstream explanations, which often seem to defy common logic, really, and are at least open to possible alternatives, then this book should be of interest. It is a collection of 44 papers, many published through not in mainstream physics journals, which essentially ban anything that does not toe the mainstream line. Written over the past decades as a result of my examination of many of physics, especially cosmology's sacred tenets. Many are investigations via mathematical and physical analysis into the plausibility of alternative theories. The 44 papers are divided into 6 topical areas. And we're going to be looking at those areas. Actually, I can't believe, now what's going on here? Let me go back here. Hold on. Bum, 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 bum. Do I have to get out of this again? Sorry, folks. Here we go. Getting back to here we go. I don't know what I did. It's like I skipped this or something. Here we go. I don't know why that happened. But somehow I had it. I'm going to get this right, folks. This is what happens when you have all these controls. And where's my crew to do this? From current slide. There you go. This was supposed to be before all this, and and I had it in my bumper or stinger or whatever you want to call it. These are some of the models of gravity, space-time. Well, I wouldn't put it as a model; it's a theory. How about that? There's nothing there, but it's a theory, a mathematical theory. And of course, there's particles, a graviton sort of theory. There's the ether theories I try to describe it, and there's the electric universe theory. So those are the areas we're going to be looking at today. But before that, I want to bring up our guest, who is in the green room. And I see we got lots and lots of comments. I want to welcome everybody. Thank you for showing up and coming. But we're going to bring him up here. Let's see if we can get him here. Wow, the green room is full. There he is. He's in the dark, but he really isn't in the dark.
That helps.
That helps. Hello, Ray. How are you?
Good. How you doing?
Well, very good. So tell us, before we start, tell us a little bit about your book. I mean, that's pretty exciting that you published them all together. Tell us a little bit about that.
Well, as you have mentioned, I first got interested in this when I I came across the late Dr. Paul Marmet, and the website Newton Physics, where he has basically used classical physics to explain several dozen of these so-called sacred cows of relativity and cosmology, etc. And kind of what I did is, in the spirit of what he did, is, though I don't have his physics background, is to look at different sacred cows and see if it's possible to have alternative explanations. In his case, of course, he developed his own theories. In my case, I looked at theories that others had developed that were non-relativistic, non-mainstream cosmological, and I just tried to examine them for plausibility. And also, I'm not doctor, but it should be Dr. Stephen Crothers, his website, where he went back and originally researched Schwarzschild's original paper, where Schwarzschild showed that there aren't black holes, and that the existence of, for the past 100 years, the existence of black holes mathematically has been based on an error made by Hilbert, a renowned mathematician at the time, in interpreting some of the parameters in Schwarzschild's equation. And unfortunately, Schwarzschild was killed during World War I before Hilbert began investigating his work, and he never had a chance to clarify anything. But Stephen has done that, and he's, of course, published numerous other works, along with questioning Big Bang and all sorts of things, neutron stars. And his website is pretty famous. And I believe I've met Steve at the Electric Universe conference in 2017, and I believe he has probably been to some of the natural philosophy conferences. I don't think he's been to any of the JCNPS ones yet. So that's
no, he wasn't. Yeah.
So that's what got me started. And this was around 2010. I was still working at the time. I'm retired now. And I was looking for, I was basically just going back and looking at relativity and stuff and the twin paradox. And I had a lot of physics in college, and I looked at these things. I'm saying, gee, these are awfully hard to follow in the relativistic world. I can sort of follow the explanations, but they really don't seem to make a lot of sense. So I started searching the internet, came across Dr. Marmay's work, and then I discovered that there was this organization called the Natural Philosophy Alliance, which happened to be having a conference in 2011 at the University of Maryland, and I live in Maryland. So I said, hey, I'm going to go and see what this is about. So I went over there. I remember sitting at lunch with you, Dave, during the during the first lunch break, and the Electric Universe people were there at the same time. It was a co-conference, so that was the first time I had been introduced to any of their theories with Paul Thornhill and those guys. But it was a very interesting conference. I was basically shocked when I heard theories of growing Earth. I had absolutely never heard of expanding Earth theories, and there was a session on that, and that I started looking up papers on that as well. And in 2017, got to meet Dr. Maxwell and at the conference up in Vancouver and studied his works. I've written a couple papers on that as well. And like I say, I don't support or deny it. I just look at the theories and see if it's mathematically plausible. So after the 2011 conference, I actually wrote a paper for the 2013 conference. It was still a Natural Philosophy Alliance, which was again at University of Maryland, and I gave that paper. Again, the Electric Universe people were there, and they had some interesting presentations, a lot of good videos about the surface of Mars and how it looks like a plasma discharges, etc. And unfortunately, after that conference, the NPA kind of went wacko, and there was all sorts of political machinations and stuff like that, and it basically dissolved, and you and some of the other founding fathers of JCNPS reformed JCNPS, and so it has been the successor to that. And we've had those conferences from 2015 through 19. Last year's was canceled because of COVID. And ever since then, I've put in four papers at a time at each of those conferences. And so what I decided was, since I had published about half of the papers, they're all in VIXRA, because if you try to publish in archive.org, you will be chastised for not towing the mainstream. You need to get a sponsor, and absolutely nobody will sponsor you unless you're spouting at the sacred altar of relativity. So I published them all in VIXRA. Of course, I've got the publications in the JCNPS proceedings, but I just decided to go ahead and put all 44 of them into a book, because I found out it's really easy to self-publish on Amazon. I had just put together a book of all my poetry for the past 30 years, and that was so easy to do. And so I said, why not do the same thing with my papers? Because they're already written. All I got to do is format them a little bit. And so that was kind of the inspiration behind that. And so that's out there. And like I say, all the papers I presented at JCNPS are in there. And roughly the other half, the other 2 dozen that are yet to be presented when we have some more conferences, they're in there as well.
Well, that's just super. I mean, I like the you got the renegade physicist.
Yeah,
So
I got my T-shirt too. I made that up. I've always liked the term renegade physicist more so. I use dissident all the time or alternative to
Right.
be more politically correct, but I like being considered a renegade.
right. I think the Electric Universe people use Maverick. So yeah. So it is. So if you haven't read his work, Galucci's work, you should. It's really interesting that you now one of the questions I think people give you, and before we're going to watch, we actually have 3 videos, one on pushing gravity, one on ether, and one on
Just blink out. There you go.
okay, so yeah, that's going to be connection problems, but yeah. So we've got 3 videos. I don't know which videos, how many we'll get through today, but we're going to watch them. But one of the things people probably often ask you is that, well, which model do you subscribe to, right? Are you an etherist? Are you a particle? Are you a lattice? And what is your answer to that? I already know the answer.
My main answer to ether versus particle is that if I'm a particle, the particle people need to explain to me why there would be a limiting speed of light if there is such a thing. I can understand with the ether people because if there's ether, it's a medium, and waves have constant speeds, limiting speeds. So I can see the argument that there's a limiting speed of light with for the ether people, but I don't see there being a limiting speed of light with particle. And I've written papers on both, and I don't when I'm in the particle, when I'm writing a particle related paper or something, I don't limit myself to a constant speed of light. I'm on the fence with both of them. Like I said, the only thing I hold to is that if there truly is a limiting speed of light, then I see that as favoring the etherist more than the particulist, because I don't see why a particle should have any limiting speed. I don't believe in infinite mass increase and infinite time dilation and all that stuff, because I don't see the relativists don't give you the physics as to why does mass increase. Yeah, the math works. I mean, Ptolemy's system worked great too for explaining the solar system, and
right.
Einstein's relativity equations work. But just as Ptolemy didn't have the physics right, who's to say that Einstein has the physics right? There's
right.
other, say, Dr. Marmé and Kurt Renshaw's theories, and I mean, there's numerous other theories on variations in light speed, and even the etherists have their own explanations as well. And
right.
the argument I'm making for the etherists is, if there's really an ether, how do we detect it other than by secondary means? Like, is the limiting speed of light the proof of the ether? Why is the ether invisible, imaginary, and non-substantial? I really wish there was some way to feel the ether. So that's why I sit on the fence. I mean,
right. I understand. Well,
have good arguments.
Yeah. Well, it turns out that my dad and I's book's coming out soon, and we have an explanation about the speed of light and particle model, why it averages the speed of light. We have a very simple explanation for that. And also, we also don't believe it's constant. It's more of an average. I think. Yeah. There's no constants, anyways, in physics. But anyways, let's not get all involved. We got a lot of people here shouting their favorite ideas about what gravity is. Now, what I decided to do, and I'm pretty sure we're going to be coming back, Ray, so I don't think you're going to be, we're going to do this in one sitting. But what I decided I would do would be to take 3 videos from your talks on 3 different aspects. Now, it could be easy to go to ones that are more popular. And if you want to put them in popularity, what you have are ether and the electric are much more popular. The particle Lesage is less today. My father and I's theory sits in that one, but that's okay. But I think it's important that we look at all of them and understand what they are trying to explain. Because one of the things I think that happens is if a person comes in through the electric universe, there's a tendency for them to think only in those terms and to think, well, there aren't any other models. This is the best model, and they don't even consider maybe an ether theory that has gravity built in, like Shaw's, right? Or they won't even consider a Lesagian theory, which of course, again, we have our book coming out, which is based on that, and we have magnetism, we have electricity, we have light, and we have gravity, all with a particle model. But I think what's really important is one of the things I see people failing to do, and this is something I don't do, even though I have my father and I have our own model. I always look at other people's models. I always look at them for their viability. Maybe they're going to have a better model than me. And I think that's one of the things that we need to try to get across. And one of the things I do like about your work is that you look at the plausibility of each one of these. So what I'm going to do today is we're going to look at, starting in order, of least to most, I think, will be the particle model, Lesage, and you gave a talk on that. We're going to look at that talk. And then we also have the talk on the ether model. In this case, you'd look into an ether model, which is the Shaw, which I call the Vancouver.
Okay.
Yeah, I call it Vancouver because he was inspired by the fog and all that, the
That's a
clouds.
hometown.
Yeah, that's what I told him. I named it, so I get, if that becomes the theater.
That was the most wonderful campus. That
That was so beautiful. I mean, it was a great time. So I have a video lined up for that, and then the last one is your presentation on Electric Universe, which has gotten over 40,000 views. Of course, the Electric Universe video viewing ship is huge. I remember when I first started my channel and I only had 100 subscribers. They passed 100,000 and they're way to 200,000. So they got a big group. So we're going to do it that way. And I know a lot of people are going to sit there and go, "Hey, this is wrong." Folks, remember what I say. Learn and understand other models. The jury is still out. The world has not shifted to an electric explanation for gravity. The world has not shifted to even a graviton idea, even though they talk about it, they haven't. And the world has not shifted to ether theories. So we can all sit here and yell from the top of our lungs what we think it is, and that's fine, but we should all understand what they all are, because if somebody else's model happens to pop and it isn't the way we think it is, you're going to be sort of caught cold, and it's good for us to know. So Ray, what I'm going to do is I'm going to take you down, bring you down here, and I'm going to put up the first video, which is about 16 minutes, which we're going to take a look at, and we're going to talk a little bit with you. Probably not have a whole lot of interest necessarily in the people talking, other than telling everybody that it's not this. So, but I think it's really important to show each one of these, fully sort of explained. So I will go ahead and do this, and I will bring you down right now, and I will get up the video and hopefully do this right. And this is from CNPS at the University of Washington in Seattle. It was from our last conference. And so we're going to be playing this video for you. And hopefully it will all work. Now, I need people if you can, in the chat or in the private chat for the people in the green room, please let me know you are hearing this. It's very important for me to put up there and have this actually playing. So I'm going to stay up next to it until I get thumbs up from the gallery, the green gallery, that they are actually hearing this. Okay? It should be, you know what? I'm going to do something. I'm going to remove this. I'm going to unshare, stop sharing, and I am going to share it again, because I'm going to make sure I've got the audio clicked on that, and that's what I'm going to do. And let's try that again. So got it. So now I know the audio for sure is hooked, because I didn't want to start that without it, but I will look for everybody to give me a thumbs up. Please do that And here we go. This is Ray Gallucci and his presentation at our live conference at the University of Washington in Seattle from June 26th to 29th in 2019, the John Chappell Natural Philosophy Society. Nothing's happening. He's not saying anything yet.
Okay, like Randy Quaid said in Independence Day, hello boys, I'm back, and so you've got to put up with me again.
You hear that?
I like to blame a tribute or maybe blame my papers on the works of others.
Oops, sorry.
So yesterday I was able to blame what I did on Halton Arp. The one I just gave I could blame or attribute to the work of Duncan. This one I'm going to blame on Bob the Hilster because I had never heard of pushing gravity until the 2005, the first conference that we had down in Florida in 2015. He had a couple of papers on pushing gravity. I said, where did this come from? And so I looked it up and said, hey, this is interesting stuff. So I'll blame this one on Bob. He's a mad scientist anyway. Actually, though, the real people to blame for this go back to 1690. Fadio was the first one to come up with this. And he sent it in 1731 to the Paris Academy of Science. Lesage got a hold of it in 1748. And they had a theory that gravity is a pushing force that involves shadowing of omnidirectional particles that impinge on all matter so as to appear as an attractive phenomenon. So let's look at a special case of a large distance between spheres. Mathematically model gravity as a pushing force with shadowing and include the possibility of acting throughout the shadow corridor of the sphere with an attenuation effects to suggest a possible alignment with one of the known effects of gravity. Gravity is inversely proportional to the square of the distance between the sphere's centers. So I decided to look at the Lesage, the Fadio-Lesage math to see if I come up with this inverse square relationship. This does lend some credence to the theories of Fadio and Lesage and has been supported by many dissident physicists, including members of the gravity group, which, are they still together? No, but there was a gravity, about 4 years ago, there was a gravity group with Bob and a few others in there, and they had the paper. So again, I can attribute this work to what I learned back in 2015 at the first conference. These are the diagrams you typically see. Up here you see the two spheres, you see all these little particles going back and forth, and it doesn't show real well, but they're less dense in between the two spheres. And they also got little holes, so these look like wiffle balls, because they do postulate that the spheres can pass through in some cases, but there is some shadowing, which is shown below. So despite repeated rejection, this theory has survived over 300 years, even been reviewed by dissident physicists as mainstream physicists continue to struggle with an explanation for gravity. They come up with gravity waves or gravitons. They propose in connection with gravity as a four-dimensional wave phenomenon. I don't know what the fourth dimension is, except I don't think time is a dimension like the other ones. Shadowing is inherent to explanations of gravity as a pushing force. If a force is transmitted to a body from something pushing on it from all directions, the body would remain stationary. That's this one here. So we just got this sphere sitting alone and everything's pushing on it equally, and it's like a balloon with equal air pressure. If a second body is brought close to the first one, part of the impinging force on body one would be blocked out and cause a net push towards body two. So body two gets in the way, it blocks out this arrow and a few of the other arrows here, so all of a sudden, these three arrows here don't have anything, or well, at least this arrow here doesn't have anything to offset it, so one would start getting pushed towards two. And if I showed arrows on number two, you would see that this arrow here on number two is not offset on this side because of the shadow of number one, so number two would start approaching number one. That results in what would appear to be an observer, to be an attraction between the two bodies. So push, pull, they can be equivalent, at least they can appear to be. So I decided to look at some geometry. So I got my two spheres separated by a distance d, there's d down here, between centers, with radii r, the bigger capital R for the big one, small r for the small one. The mass is 4 pi, capital rho, looks like a P, for the big one, 4 pi, small rho, for the little one. The gray arrows here on the outside, they show are omnidirectional pushing forces. whether they're particles, waves, or combinations. And they're the ones, they remain unshadowed, except for this little part here, which is, as you can see, between the two spheres, that this part here is blocked out on this side, so you do have a net push over this 2 theta on the small sphere. You have a net push over this 2 phi on the larger sphere because of the blockage between the two. The net pushing force results from area over which the pushing forces are not offset by equal and opposite pushing forces diametrically opposed. That is, the cones, again, this is a 2-dimensional picture, but they're spheres, so this is really a cone with a solid angle type of thing. Not offset by equally and opposite pushing forces diametrically opposed. That is, the cones of radius r, bigger sphere, and small r, little sphere, with solid angles phi here on the big sphere, theta on the small sphere. When far apart, d much greater than r, and since capital R is bigger than small r, d is also much greater than small r, we can simplify the geometry. Any exaggeration here is for clarity. Essentially, this triangle here, when the d is real large, is essentially a right triangle, the same over here, and so I can do some simple calculations just using Pythagorean, and what they both end up with is that the cosine of theta and the cosine of phi end up being approximated as the separation distance over the separation distance, so it ends up to be 1. So that'll simplify some stuff. The net pushing force on each sphere is proportional to the cross-sectional area subtended by the cones of the 2 different radii. That's the sine functions here, pi r sine phi squared, sine theta squared, effectively acting along a vector parallel to that between the centers of the 2 spheres. With the separation distance much greater than the radii, each of these simplifies to pi times the product of the 2 radii over the separation distance, that ratio squared. Each sphere has inertia proportional to mass, resisting each pushing force. So if I accelerate each sphere, it'll be proportional to the exerted force divided by the mass, such that the accelerations become as follows. So the larger sphere, here's the force, and here's the mass. So this is the acceleration on the larger sphere. In the smaller sphere, here's the force, same force, but slightly different mass. It has small rho, small r, so this is the acceleration on the smaller force. And lo and behold, both are proportional to the inverse square of the distance. They're both proportional to 1 over d squared. Now, strictly speaking, these accelerations need to be multiplied by the change in momentum per unit area from the impinging particles. So I have to, just to be dimensionally correct, I throw in the term delta here, which actually has units of kilograms per meters per second squared. The first part of it, kilograms per meter per second squared, represents the change in momentum, kilograms per meters per second, coming from the impinging particles, sort of like the ram force that Duncan talked about earlier. The second is the inverse of the impingement area, the surface area. So the accelerations are more actually written with the delta term in there. So the same accelerations as before, now I've put the delta in each one of them. Dimensionally, each acceleration now has the correct units of meters per second squared. So that's just to make things a little cleaner here. Now, within the spheres, so far I've only considered the spheres as solids, impenetrable solids. That is, the pushing force acts only at the surface. Fadio, Lesage, and the gravity group, and others who espouse gravity as a pushing force, usually assume that it has an effect going throughout the target, that is, as it passes through the sphere. Let's consider the pushing force acting not only just at the cross-sectional area of impingement, but throughout a cylinder as it hits the surface area in a small circle. Look at as it passes through in that, extending through the sphere whose axis parallels the vector that connects the centers of the 2 spheres. Now I'm going to include the linear distance through each sphere that the particles theoretically pass, effectively multiplying the previous results by the diameter to obtain the following accelerations, because it acts throughout the diameter, so twice the radius. So the larger sphere acceleration now has an additional distance of 2 capital R, the smaller sphere 2 small r. So the accelerations become these formulas here. Again, they're the same except the r's the r's and the rho's switch, the dependence on the inverse square of the separation distance remains evident, but now without the inverse dependence on the radius of the sphere itself. If you remember previously, there was an additional distance term in the denominator. There was a capital R in the first one and a small r in the second one. These terms in red have now disappeared because I've interacted them over the entire sphere. Dependence on the square of the radius of the outer sphere, of the other sphere, that is the one that shadows remain. So I still have my d squared dependence, which is what I wanted. I don't have a distance cube type of thing, which I would have had if I still had the radial distances in the denominator. Proponents of gravity as a pushing force sometimes assume that in addition to the shadow effect, the force itself may be somewhat attenuated as it passes through the sphere. There's some sort of interaction that may actually either slow down the particles or absorb some of the particles, and that's really where the shadowing comes in, because not all the particles that go in go out as they come into those angles. Attenuation over a linear distance x is usually modeled as an exponential decrease, 1 over e to the mu x. Mu is some form of attenuation coefficient. It's usually some function of the density. Here I don't specify the exact functions, just the capital F of capital rho for the larger sphere and small f of small rho for the smaller. Now if I throw this into the acceleration as another multiplier, I end up getting, they're in the denominator, so I have what I had before, 3r squared, the delta 2 rho d squared, and now in the denominator I have this exponential term, which since it's positive is going to be greater than 1, and so it'll show that the acceleration has decreased because of the interaction. And now we're just forming for the smaller sphere. Once again, the dependence on the inverse square of the separation distance is evident. I still have d squared in the denominator, but now I have some reduction due to attenuation. I have this exponential attenuation form, which I put in the numerator, which should have a minus sign on it. A ratio of accelerations larger to smaller on the two spheres yields the following. So here I'm taking the ratio of the larger to the smaller sphere's acceleration. So I get that it's the ratio, it's proportional, well that's actually equal because I'm doing the ratio of the two radii squared, the ratio of the densities, and it has the exponential term, which is 2 times the difference between the product of the radii and the mu function. Again, the attenuation function, which instead of writing the mu here, I've written as f of rho and f of capital rho. Again, r is greater than r, capital R is greater than small r, so the first term likely will dominate. Unless capital P is much greater than rho. For example, comparing a neutron star to a typical star. So then that could dominate. Or f of rho is greater than small f of small rho. What I'm trying to show here is that the acceleration on the larger sphere is always going to be smaller than the acceleration on the smaller sphere, because like the Earth and Moon, the Earth's gravity on the Moon is greater than the Moon's effect on the Earth. And it tends to fall out from here. Again, the smaller sphere, the larger sphere, the ratio, this is less than 1. Unless the densities are grossly different, this term is probably around 1. And unless the, again, function of the density, if the densities again are fairly comparable, then these terms are f of rho and capital F of rho are probably similar, and you'll end up with a somewhat negative value here, so that becomes e to the minus something because r is bigger than r. So it shows that the ratio should be less than 1, which is what we expect. Again, the acceleration on the larger sphere is less than the acceleration on the smaller sphere. The effect of the larger sphere feels less acceleration than the smaller sphere. Acceleration on the larger sphere should most often be smaller, should be less than on the smaller, implying less movement towards their mutual barycenter on the part of the larger sphere. That's consistent with observation. I mean, the Earth and Moon, they rotate about a barycenter that's about 1,000 kilometers below the surface of the Earth. So it's kind of a wobbly thing, and that basically the Moon has been drawn a lot more closer to the Earth than the Earth has been drawn to the Moon. So in summary, at least for large distances between spheres, a mathematical model that assumes gravity to be a pushing force, with shadowing and including possible attenuation throughout the shadowed corner of the sphere, suggests a possible alignment with one of the known effects of gravity. It's an inverse proportionality to the square of the distance between the sphere's centers. I've hopefully lent some credence to the theories first proposed by Fabio and Lesage and since supported by many dissident physicists. After I wrote this paper, I found a really interesting derivation of Newton's gravitational equation from Lesage's attenuation concept. And this addressed not only the inverse proportionality to the distance, but also the direct proportionality to the product of the masses. This is a reference for that. And if you're interested in this and you want to do more than I did, which was also bring the masses directly in there. I mean, I had the masses sort of in there in terms of the densities, but these guys were able to get the mass, the product of the masses in the numerator, so they were able to show that pushing gravity can yield directly Newton's gravitational formula.
Okay, let me get you back here. So that was a great presentation, I thought. It gives people an idea because, like I said, so many people have the, man, hold on, let me get through this. I've got to get, I'm fighting with the PowerPoint and slides here, so hold on.
I have to get one.
Yeah. Well, actually, I had it made. I went to the mall and had it made, Physics Police, because I actually had an idea for doing a Physics Police whole series on it, so where I'd have people who were acting like cops, a real cop. Imagine the whole storyline would be like a South Park. In South Park, what we do is you have these physics policemen, and they go around and, you know, I had a little scene where Einstein was driving a Volkswagen. He gets pulled over for going close to the speed of light and all that, and that kind of thing. But the idea was we need a physics police that when people say things that we need to police them. And that's sort of one of the things that you sort of do in your work. I mean, you describe it as a person who really works on evaluating plausibility, right? And so when you had, I think it's interesting here is that you had never heard of a pushing gravity. I mean, one of the things my mom, who in the documentary, she went up to one of the great scenes in my documentary is when this person's talking, and my mom is discussing things, and she's a total layman, right? And she went up to a person and says, "Well, do you think gravity's a push or a pull?" And the guy goes, it totally stumped him because he never thought of that. So when you looked into that, that was a totally new idea to you, but you see that as mathematically a plausible model for gravity then.
Well, especially the work that when I found Newton's snow after I did my investigation, and their derivation is cleaner than what I did. They get the entire they basically write the entire gravitational formula. Only the square distance. They have math as well. But I was just trying to look at it. It makes sense. The idea of shadowing. But
as far as
the R 1 over R squared.
I understand. Oh, yeah. Hold on. I need to do something here. Thank you very much. Okay, go ahead. Describe that again. I apologize. Thank you very much, Franklin, for jumping in there for me. I need to do that sound. He's got more experience than I do, so go ahead. Say that again.
I found the Mixed and Stowe paper after I had written what I did, and theirs is a cleaner derivation of the full Newton's gravity equation with not only the inverse distance squared dependency, but also the product of the masses. But at the time when I first heard about this pushing gravity from your dad's paper, it made sense. The idea of shadowing, decreasing the push in between the two bodies, and that would make them come together a little bit. So I said, well, let's see if it satisfies math, because the one thing I've found is that while there can be many explanations by different physicists for these various phenomenon, the math always has to work out. So for the pushing gravity to be plausible, the math would have to work out at least in the inverse square of the distance. And so that's what I went. That's something that's fairly easy to do, just looking at geometry. And so that's what I went ahead and did. I try to work within my capabilities. I mean, it's like yourself. I'm fairly good with the math. I know a healthy amount of physics from my college days and etc. And so I just basically work with what I know, and usually try to look at simpler explanations. I mean, I don't get into tensor calculus like Steve Crothers gets into when he does his derivations, etc. Because I try to teach it to myself, and I just didn't grasp it. So I try to do things that are fairly simple.
Right. I think is another interesting thing for you to know is my father, when we were making the documentary, he had actually modeled what you were doing was using force equations. He literally took small particles and traced them through mathematically and did calculations of all the little forces. So he didn't take the force equation and do a summation or an area. He literally took particles and and made them go through the masses, two masses, for instance, and did the calculations. And it took so long that I had to get a math package in C++ that would do types of calculations without slowing down. That is, when you had big numbers, he was literally using 150 decimal places for his calculations because they were so small, right? And when he was adding and doing those calculations, of course, your computer's going to grind to a halt. So what I did is I got a math package from a university that allowed you to do these humongous calculations without any slowdown. And yet, with that, his calculations took up to 3 to 4 days on a pretty good computer at that time. And so it was another verification that the shadowing effect is doable. I mean, is plausible, because what he did again was not to do one, just the overall effect. So that was pretty good. Now, I'm not sure anybody in the green room wants to talk about this. I know this is just not popular. My father and I, again, we use this model, but most people are. Those people are more interested in an ether model or a more electric model. I don't know if anybody in the green room wants to say anything. I don't see anybody probably in the... do I see anybody with their hands waving? Oh, we do have Ian waving his hand. So I will bring up Ian here. Hello, Ian.
Hello, David. Hello, Ray. Yes, thank you. I thought I just might come in here quickly following your invitation. One thing that I have been thinking about this sort of particles impinging upon material is that the resulting gravitational force would be surely statistical, and therefore it wouldn't be constant. You'd have a variation, but what we observe is a very constant, very stable gravitational force. So that's just one problem I was thinking about. I don't know how you would explain that, Ray, maybe.
I don't see where, once you have the shadowing with the Earth Moon, the distance remains the same, so the shadow pretty much stays the same, and so the gravitational force would remain pretty much constant with the pushing effect.
Yeah, I know what you're saying, Ian, and my father actually, and I have thought a lot about this, obviously, if we have a model about this. And he came up with a statement that sort of blew my mind, one of the statements my dad makes once in a while, and that is, no two collisions in the universe happen at the same time. None. That is, the idea of simultaneity. If you can get down to a time frame, he made a statement that no two collisions in the universe will ever happen at the same time, which means you're going to have that in no matter what you do. And so it is going to be an average It is going to be something that's constant in the sense of a time frame, but in reality, it's not. It's being pushed. There is no collision in the universe. I believe that. I believe in infinity in the sense of divisible time. Infinitely can be divisible, meaning you can get down, if you got down to a point and you were seeing every particle in the universe, you'll never find a simultaneous hit. Then you got to imagine, well, if you believe that it's a force and all forces in the universe are caused by mass hitting mass, which it's our model, then yeah, you're right. In a sense, it's an average and there's a movement, just like Brownian motion, right? So yeah, in reality, yeah, I mean, there's movement everywhere. When we think there's no movement, it looks like it's not happening. It's steady. It's not. So in our model, we know that. But in a scale where we see it and where we measure it, that's what we're seeing, because we don't have the sensitivity of that kind of scale to be able to see those kinds of things. Whereas, and I don't know if you've seen the Brownian motion sort of videos, you can see the same sort of thing moving around. It stays in a place, but if you get really close to it, you can see it isn't stable either. So we subscribe to that, and that's a model we use. So we agree with that. But to measure it, and again, if you have a model of everything, in our model, it really would be really, really, really hard to measure. So,
one way might be to engage in some modern version of Cavendish experiments in the laboratory. Using very accurate model equipment, which Cavendish didn't have hundreds of years ago.
Right.
To see, was this constancy maintained or not?
Right. And actually, our movie, the documentary we made, was based on an experiment. My dad got into this because I asked him to help an experiment that Dr. Riccardo Carrazzani, a Argentinian physicist who believed that gravity was a push, that it was a particle, had developed in order to prove that the particle, the graviton, existed. We did an experiment in the movie to try to do that. But the problem was our accuracy in our garage was not even close. It was doomed to failure. But what it ended up doing was giving us, my dad, an inspiration for a particle wave duality solution, where now you look back on it and oh, that's great. Now whether or not that's right or not, that's a different story. But we were the experiment you're talking about was proposed by Dr. Carrazzani in the 1990s on how to do a Cavendish experiment that would show that you could block out. I won't get into it, but that's in the movie. So that is an interesting idea, and it's already been thought of too. So, any other comments or? Nope. Okay. All right, Ray. I think what we're going to do is, again, I know that the particle model is not going to draw lots of interest, and I'm not even worried about that. It's more important for us to take a look. I'd like to, I think, get one more video in, and that is on aether. And now I do know that these are technical. A lot of people aren't so technical, but I think it's good to get into the idea of just seeing two things. I think is very important. One is that there are more than one model, right? I mean, you've worked on several models, right, Ray? I mean, that's absolutely true. Yeah. And the other thing too is
model is an ether model.
Right. And so you have examined several models and put them through a rigorous sort of, how do you say, understandable test mathematically. I think they've all come up. Yeah, simplified, but they've all come up as plausible. And so what I think those are the two things are, one, there's more than one model. So if you're an aetherist, you got to understand there are two other types of models out there. Number two is that they seem to be plausible. So, I just want to caution our audience to making, I hear people say there has to be an ether. No, what you need to stop saying there has to be an ether and say there should be a physical model for light. That we all sort of agree on. We need to have a model. We talk about light as space-time, but that's, I think, one of the things I'm trying to impress with your work on other people. So I'm going to bring you back down again here and see if I do this right, and I'll remember. Thank you, Franklin, for jumping in. Appreciated that I had that echo going on. That happens, folks, when I have the computer's, audio going on. So I'm going to bring this up there. This is another talk that he gave on in the same conference. Now, I'll maybe, in fact, what I'll do is I'll bring you up again, Ray. Why don't you tell a little bit and introduce what you're talking about real quickly, just in a couple, about a minute here.
Am I up?
Yes. Go ahead.
So this is Duncan's model, right?
Right.
Okay, so when I was looking at with Duncan's model, he basically looks at ether flowing into large bodies. So like ether flowing into the sun, flowing into the earth, basically, and kind of like a ram force. And
right.
He has to handle the ether going back out, or else it would build up. And he
right.
does that as well. So he has the ether coming in at a certain speed and going out at a certain speed. I believe he has a change in temperature effect as well.
Okay,
and,
so in other words, you took one of his model, an ether inflow and outflow model, and did some calculations, right? And this was at the same conference.
Yeah.
Okay.
Duncan doesn't attack the math. It's not up his alley too much. So
right.
What I like to do is when I see one of Duncan's theories, I like to put some math to it, and I ran it by.
This is the result. Okay.
He was okay with it. I mean, I don't pretend that my explanation is the right one for his model, but I did find mine as at least one possible explanation that would support his beliefs in the inflow outflow of ether.
Okay.
Having a gravitational effect.
Okay, so let's take a look at that, and that's what we'll do here. So I'll start this off. Give me thumbs up and thumbs down, folks, if you're hearing this, and hopefully we'll get through this and then discuss. Again, he's saying nothing right now.
No, we still don't got any sound here.
Oh, you're not getting sound? Okay. You're not getting sound. Is that right?
Yeah, we're not hearing him.
Okay. All right. Well, I needed somebody to give me a thumbs up. I saw nothing there. So, okay. Sorry about that. Let me try this again. I will bring this down. I do apologize, people. So let me remove this. Also, stop sharing screen. I'm going to do this again. Make sure I got this back to the beginning. I do. All right. And here we go again. Sharing with audio. What happens sometimes if I click around, that's one of the things, unfortunately, I can't seem to mute my microphone. People say you hear me breathing. It's because they weren't hearing him. So we're still living with this new technology here. So let's try this again. And please, people in the green room, give me a thumbs up or thumbs down so I know this is working or not. There's silence right here.
Ray Gallucci up here again, and I'm going to follow up with Duncan discussed this morning, looking at some of not all of the aspects of his ether concept of gravity, but the ones with which I was able to do some mathematical analysis to see whether it passes the test of plausibility. Just before I start, just want to mention my wife found this Einstein hat at the Smithsonian, but I had to add the tongue to it, else I would not have worn it to this conference. Okay, Okay, Duncan has proposed an ether explanation for gravity, publishing several papers over the current decade. You can find them on his website, which have evolved into his ether concept of gravity. His theory, if you remember from this morning, inflowing ether into the cosmic bodies produces an accelerating ram force, manifesting as the attractive, in quotes, gravitational force without the need to postulate action at a distance. What I'm going to do is examine three key aspects of his model, which lend themselves to modeling in the form of mathematical constructs as an investigation into the plausibility of this theory solely from a mathematical perspective. In his 2017 article that was at the 2000...
Yeah, just say okay there.
That was presented in Vancouver at our third meeting, he proposed gravity as a pushing, not pulling or attractive force. It has the net effect of attraction, but it's actually pushing. The simple analogy made to a vacuum cleaner, which by creating lower air pressure inside causes air from the outside at the higher pressure to push itself inward toward the artificially lowered pressure region. Rather than sucking in air, a vacuum cleaner allows the air to push itself inward. The inflow is caused, and this is quotes, the inflow is caused by the pressure of the ether in cosmic bodies being lower than the pressure of ether in space, due to the emission of ether from the cosmic bodies. And remember from this morning, he showed inflow and outflow. The resulting pressure differential causes ether in space to flow toward the partial vacuum. Pressure in cosmic bodies is also lowered by the acceleration of inflowing ether from space to the relatively narrow targets of the cosmic bodies. As he mentioned, it's an application of Bernoulli's principle pursuant to which the pressure of a fluid that is flowing in a narrowing channel reduces as the speed of the fluid accelerates. Continuing with his concept of gravity, with all this ether flowing into a cosmic body, Shaw must address whether there is an outflow to maintain equilibrium and prevent runaway heating of the body, and he did discuss this morning. Again, quoting his work, outflow is essential because 1, it replenishes the supply of ether in space required for continuous inflow. 2, it provides a mechanism to dissipate into space the heat that's transferred to the cosmic bodies by the ram force of the inflowing ether. Heat generated by this inflowing force causes inflowing condensed ether to vaporize or evaporate into a gaseous state and flow back into space by way of diffusion and convection, where it condenses into droplets of liquid ether. And you remember his analogy, if you drops of water on a hot plate, they basically dissociate and go back off. They gradually come into contact with other ether cells, and with droplets of condensed ether, the supply of condensed ether in space is thereby replenished. This is a similar version to what he drew this morning. It doesn't show the ether flowing out. This was taken from the 2017 paper. It shows the ether flowing in to here we have the sun and a planet. But if you remember from this morning, you would also have these arrows that were going outward. Three concepts lend themselves to mathematical modeling within Shaw's theory, at least to the extent I was able to do it. First, the accelerating rate of radial inflow of ether as it approaches a cosmic body. Assumed spherical for convenience. Second, creation of a pressure differential between inflowing and outflowing ether at the surface of the cosmic body, such that the inflow pressure is greater and ends up representing an attractive gravity. Although it's not truly attractive, it manifests as if it was. Third, dependence of inflow versus outflow pressure differential on the mass of the cosmic body, such that two bodies of equal size and shape experience different gravities depending upon their masses or densities. Because if you had Venus and Earth, for example, which are approximately the same size, and pretend that Earth's a little denser than Venus, a little bit heavy, not that much. If all the ether was able to react to was the geometry, Earth and Venus would have the same gravity. But they don't, because Earth is slightly denser and more massive. So there has to be a way for the ether to know that the same size bodies, one is denser than the other. And that's the third aspect I'll look into. For the first aspect, ether inflow. Inflow of ether is dominated by the most massive sun. Again, remember the drawing, it had the big arrows for the sun, the smaller ones for the Earth. That overwhelms that of any planet except in the planet's immediate vicinity. Let's look at 3 dimensions, a spherical sun and planets. The rate of ether inflowing from an infinitesimal shell of radius d, which is distant from planet center to sun center, the distance between the planet center and the sun center, and it has a thickness of delta d over a time increment of delta t, and this is the rate of inflow, 4 pi d squared, delta t over delta t, which is 4 pi d squared, the velocity is delta d, delta over time, delta t, is the radial inflow velocity of the ether at planetary distance d. Defining the inflow rate, the velocity at the sun's surface is 1, so I don't have to get funny numbers to do everything relative to 1. And the inflow rates at the planet and the sun, since ether does not build within the solar system, you end up finding that 4 pi r squared times the velocity of the sun 1 equals 4 pi d squared v, again, velocity 1, where it leads to v equals r over d squared, in parentheses, where r is the rate, capital R is the radius of the sun. Since the radius of the sun is much less than the distance between the sun and the planets, d, the velocity of inflowing ether at the planet is much less than at the sun, where it's 1, decreasing as 1 proceeds outward from the sun. And I think that was discussed pretty thoroughly this morning, once again. Gravity results from a momentum of the sun's inflowing ether, which is imparted on the planet and is proportional to the ether mass, in quotes, impinging on the cross-sectional area perpendicular to the radial inward flow towards the sun. So we have a planet with radius small r. The impinging mass is proportional to pi r squared. That corresponds to the gravitational push inward at a distance d from the sun, which is proportional to vr squared, which is small r times capital R, the 2 different radii, over the distance, whole thing in parentheses squared, dropping any constant terms so I can work only with ratios. No gravitational constants and stuff like that. The impact effect differs significantly from a solid surface, such as Earth's, to a gaseous one, such as Jupiter's. So we do have to take into account the nature of the impact, the body on which the ether is impinging. Earth, the 4 inner planets are solid bodies. The 4 outer planets, if you push Pluto aside, are gas giants and have a much softer surface, in effect. To compensate for this and for me to do my calculations, I made equivalents of the 4 gas giants as solid planets. So basically I took the mass of each of the 4 outer planets and converted them into solid planets by shrinking them down a lot as if they're a bunch of solid planets on the outside. And it's a fairly simple analogy here. I just assumed that each of them would have a density which is equal to the average of those for the 4 inner planets, which is roughly 5 trillion kilograms per cubic kilometer, and calculate the equivalent radii based on the actual density, where rho and r are the planet's actual density and radius, so I'm coming up with the equivalent radius based on the average density for the inner planets. And you can see that this calculation there, we got a bunch here, the sun, the inner planets out through Mars. And then for the outer planets, these are the equivalent radii for the outer planets, not their actual radii. I retained Pluto. These are the actual densities for the inner planets. This is the average for the inner planets, which I use for my equivalents. And that's the actual value for Pluto. These are the distances from the sun. And this would be the ether velocity from the calculation. So then I calculated the force relative to the sun's gravitational force being equal to 1. And I did it for both the ether aspect from Shaw's model and from basic Newtonian gravitation. You can see that the ratio in both cases are 1. And so scaling to the sun's gravitational forces on Earth being equal to unity, the ratios for each plane of the ether versus the Newton gravitational forces, shown here, here's the figure, agree quite well, especially with respect to the trend, except for a most roughly an order of magnitude difference for the gas giants and Pluto. So you can see the trend here. This is Newton in red, and the ether model from Shaw in blue. And considering these types of approximations I'm making here, especially for the outer planets, that's fairly good agreement, I would think. Okay, that was, so certainly I found the first part of the aspect, which is the ether inflow model, at least to be plausible, consistent with the observed gravitation from Newton's model, which we would expect it to be. Next, I looked at the pressure differential aspect. Here we view the inflowing condensed ether capsule as I chose a tetrahedral package of 4 ether particles, each a sphere of unit radius flowing into a sphere. So I have my 4 particles here in gray to form a tetrahedra. And then what I did is, as the ether capsule flows into a large spherical body, it displaces 4 individual ether particles in a straight line. So basically, to do the calculation, I take my tetrahedra, I make an equivalent sphere out of that, and then I assume that although the ether comes in a capsule, a compact capsule of a tetrahedron, as Duncan explained, when the water hits the table or the hot plate, it dissociates into its constituents. So the 4 come in as a tetrahedral compact package, but the 4 go out linearly, like a cylinder. This is analogous to Shaw's concept of the ram force of inflow causing the inflowing capsule to vaporize or evaporate into its constituent particles. So the equivalent spherical volume of a sphere, again using radii 1 for each of my little spheres, 16.76, corresponds to a sphere of equivalent radius. It turns out to be about 1.6 relative to the unit particle radius. So my equivalent sphere here in red has a radius of 1.6. Assume it's a cylindrical volume for the 4 expelled ether particles. So they're coming out in a straight line, and the equivalent geometric figure is a cylinder. It has an equivalent length of 5.33, proceeding outward in a straight line. The average distance that it's moving is half the length, 2.667. So basically I have ether coming in with an equivalent radius of 1.587, going out with an equivalent radius of 2.667. So how does that lead to pressure differential? Because the inflowing ether is in the form of a tetrahedral capsule with that equivalent spherical radius of 1.6, its depth of penetration is going to be less than the equivalent average distance traveled by the expelled individual ether particles, 2.7. Radially, this corresponds to particles expelled at about 1.7 times the speed of the inflowing capsule. They go off faster than they come in. And as Duncan mentioned, this is related to Bernoulli's principle. So ignoring gravity at this point, a positive pressure differential results between the inflowing and expelling ether. And this is just a simplified version of Bernoulli's equation without the gravitational MGH type term in here. And it ends up saying that the difference between the inflowing and outflowing pressure is going to be equal to density, half the density times the difference of the squares of the velocity out and the velocity in. And since it's going out faster, proportional to 2.7, and it's coming in proportional to 1.6, we have a positive pressure. The pressure going in is less than the pressure going out. It's greater than the pressure going out. So without knowing the ether's density or its inflow or outflow radial speed, I can still make some rough estimates of the pressure differential requiring some subjective assumptions. So I took this off of the internet, Wikipedia, for the interstellar medium. In all phases of the interstellar medium, very tenuous. In cool, dense regions, matter is primarily in molecular form, reaches number densities of 1 million molecules per cubic centimeter. In hot, diffuse regions, the matter is ionized. The density, they say, could be as low as 10 to the minus 4 ions per cubic centimeter. We got a range of 10 orders of magnitude. So usually when you're dealing with tremendous differences in orders of magnitude, when you're going to use a midpoint, you use the geometric mean. So the geometric mean of this range would be 10 per cubic centimeter. I assume this consists of individual hydrogen atoms, which are separated. The protons are separated, and electrons, and in equal numbers if they're ionized. So the corresponding density in terms of kilograms per meter cubed would be 1.67 times 10 to the minus 20. So that's the density of the interstellar medium I use for my calcs. Again, in an earlier paper that Duncan did in Physics Essays in 2013, he assumes, quoting, a spacecraft returning from the moon are being carried by ether toward the Earth. The speeds of the spacecraft en route should be essentially the same as the velocities of the inflowing ether. For example, the velocity of the ether at a point where the vehicles reach the Earth's atmosphere must be about 11 kilometers per second when they start to encounter the braking effect of the atmosphere. And just to get a little perspective on that, that's more than 10 times higher than the maximum terminal velocity ever reported by a skydiver, which turns out to be about 0.4 kilometers per second. Somebody jumped from 130,000 feet at one point in time. So I'm going to use Shaw's estimate of 11 kilometers per second for the speed of ether flowing into the Earth as it approaches its surface. And that's weird. Where did it go? It says there's one more slides.
I don't know what's happening there. I think we got a good idea of that, Ray. So I'm going to bring you up. I'm going to pull that out. So, yeah. So you did calculations for inflow and outflow, correct, for his ether model.
Correct. I had to make up a very simple geometric model to do the pressure differential aspect.
Right. And so your conclusion was in the end that the idea of ether flowing in and flowing out was a model that in fact is plausible.
Yep. It's again, it's another potential explanation.
Right. Now, one of the things that we're going to be looking at, I think we're not going to look at it today because we only have a half an hour left. But those people who are the Electric Universe people, we're going to be back. We still have a half an hour, folks. We're not done. We'll leave this open discussion and comments from people in the green room. But we're going to, in the next session, come back and talk about your Electric Universe presentation. And so if you can come back in a couple of weeks, I think next week we have Jack, then we have Nick, and then the week after that, maybe we can, is that going to be possible for you?
Yeah, you just let me know. Just let me know about a few days ahead of time.
Okay. So one of the things is this is not the only ether gravity. Did you postulate? Have you looked at any other or read about any others with ether, how they also do gravity, or is this the only one you looked at?
I don't. Let me take a quick look here at all my at all my papers. It's hard for me to keep track of what I've done sometimes.
Right. I think there's another one somebody talked about was Dr. Glenn Borkert, who was in trained ether. And what happens is it's ether gets closer, then there's a lot more bombarding from ether that happens closer to a body. So I think he used that. So that's an interesting one. You may want to look into Borkert's explanation for an ether gravity put in ether. An ether gravity, I guess what you want to call it.
I guess I did look at something that was at least an offshoot of that. When the legal results came out a couple of years ago, where they were claiming that black holes had been proven and gravity waves had been proven, I know Steve Crothers looked into that a bit, and I looked into it as well. So I looked at whether or not the legal results were based on gravity waves or a disturbed type of ether. I also looked at the Allais effect and compared that between Newtonian and Lesaggian gravity. So I guess I've looked at the Lesage approach, the Duncan approach, and I've done the Electric Universe approach pretty much for plausibilities.
Right. And what I want to do is open it up now to talk about these gravity. I know there's ether. I know people are talking about the electric universe or electric part of what they say gravity is caused by an electrical effect. I know there are people like, I think Dr. Lucas also claims to have a theory about how gravity is part of the electrical component of the universe. I know there are people who have ether theories here in the green room, and perhaps they want to talk about what they think in a short amount of time, maybe like 5 minutes, a couple minutes. Anybody, I know, Franklin, you're an etherist. I know, Ian, you're working on ether too. If anybody else is in the green room that wants to talk about what they think gravity would be in an ether type of model. Let's see, David, here's, let me see here. Dave, there's no ether gravity. Ether is an intermediary entropic concept. It can be used as a helpful scaffold, but doesn't mean that it's an absolute reality. Okay, that's somebody's opinion. Not much I can say about that. But somebody wants to wave in the green room, wants to talk about it. Okay. I'm going to get somebody up here. Theodore, Ted, you are there. You're mute. Oh, how are you doing, Ted?
I'm doing okay.
So, yeah, tell us about, I know you were mentioning ether, but I think that it was more on the electric side, or was it an ether model?
It's more like electric and electrostatic, okay? And it involves the theory of Ralph Sansbury, which is not well known. It's a complicated sort of a book, and I think you almost have to have an advanced degree in physics in order to read it. I could give you the gist of it.
Okay.
Okay. It does answer the mail for large dinosaurs. Are you familiar with my own work involving dinosaurs and the question of gravity?
Right, yes. But you may want to mention that real quick. Again, try to keep these, pretty quick.
Yeah, give me just a second. Let me turn this stupid thing off. Hang on. It's like I've got a cell phone and wants to interrupt it.
No problem. This is the age we live in, so.
Yeah. Okay, that's off. Gravity and dinosaurs. Right, I've been able to demonstrate that there's an absolute limit on the Earth at present of about 18 or 20,000 pounds for land animals. Beyond that, anything would be crushed by its own weight, right? I mean,
right.
That arises from simply equating one of these maximum powerlifting events, to the idea of a person just standing up and lifting his own weight off the ground, which you could do. You could take one of the strongest humans we know anything about.
Sure. We're familiar with Stephen Hurl's work as well. So you're saying, explain. I know that's not an ether, but since you're up here, maybe in a couple minutes' time, you could explain what this idea is. It's got to be brief, though.
Okay, Ralph Sansbury's work is interesting because it does not start with any kind of a back of the book search for an answer involving gravity. Right, it starts with a very mundane study of wires and electrical currents creating electrostatic fields, right, transverse to the current. It's not supposed to happen. It's a very small effect, but it is measurable. It does take place. And when you reverse the current, the electrostatic field reverses. Now, Ralph Sansbury's explanation for that is astonishing. He says basically, there's no such thing as a point particle in real life. Anything that's physical has real dimensions. Okay, for the last 100 years of thought of subatomic particles, electrons particularly, as being atomic, as being point particles. Right now, Sansbury claimed that an electron is basically a small orbiting system of its own, which has like a central particle and at least one orbiting particle, the charges of which sum to that of an electron. Now, what he claims is that normally at rest an electron is spherical, right? But if you subject it to a force, it becomes stretched and ellipsoidal. Okay, at which point, in other words, in its spherical form, it does not represent any sort of a dipole. When you stretch and make an ellipse out of it, it does, like the voltage drop across a wire subjects the electrons to a force which stretches them into ellipsoids. And he claims that this is, and of course, when you reverse the current flow, then it's going to reverse the electrostatic field that generates. Okay. The computed necessary speed of a sub-electron particle, which Ralph Sanford called subtrons, would get you from here to Andromeda in a couple of seconds. You need to think about that for.
But I want to pull back a little here because we're going to try to stay on the topic and not get too much in detail. Is his model more of is it because of by electric field? Where's the force coming to push the moon toward the Earth, for instance, or an apple to the ground?
Okay, these electrostatic dipoles being created by ordinary spin forces in the case of gravity. You know, so that you have gravity being a kind of a second or third cousin to gyroscopic force and things like the forces that create sinkers and sliders in baseball. Okay.
But it's through a field, an electric field? Because if you have an apple, you're talking about sort of subatomic forces, which are very small. But an apple compared to the Earth is a huge distance away that is between the two. How is that? Because one of the questions would be when you have a gravitational force, if you're talking about what's things that are happening at a subatomic level, what's happening? How does an apple and Earth interact with what compared to subatomic is ridiculous amount of is it a field?
You're having to look at all the electrons in the wire or all the electrons in a planet like the Earth. Okay, it's like, and I believe also that you have to consider all spin forces which the Earth or things on it experience, which would include the rotation of the Earth itself, the revolution of the Earth around the sun.
Right, but is it a field in the end? That's because if you have, I understand what you're saying, but what I'm saying is the
field.
Okay, and the field of these things reaches way beyond the subatomic level.
Yeah. Oh, yeah. Absolutely.
Okay. All right.
Gravity propagates instantaneously. You're aware of that, right? I mean,
well, I mean that is an idea, but we found 2 experiments during solar eclipses where gravity and light are shown to arrive at the same time. So there are different ideas about that. But okay, I'm also gonna pull you down a little bit. But I appreciate that. We're gonna next time we're on gravity, we're gonna be talking about electric, and we'll maybe you may even want to talk about thinking about talking about the idea the theory that you're talking about, but I appreciate your input for right now, and greatly, we can go on with these a lot. I do want to get to some of the, there was the interesting question I put up there, which is this, and it is true. What is electrical, Dave? And I have that same question. Is completely understood a reality, or from what I know, it isn't. This is again talking about poetry, unless you have a model. Of course, as an example, we know exactly in our model what electric means, and it's a physical explanation of particle flow. Now, one of the things we do talk about constantly are fields and electric, and what does that mean? The universe is more electric. Well, what does that mean? I think we have to be very careful when we are looking at gravitational theories, whether they're ether, whether they're particle, whether they're electric. In that we don't use words without understanding, without making sure we understand what those words really mean. So I totally agree with that statement. We've got to understand the words we're saying, and not just get totally involved in the system. A lot happens when a person has a gravity model, whatever it may be, even a lattice model. There's a tendency to get into all the not the mechanics, but in the logical way things work, and fields and other forces that people talk about but don't describe in a physical way in the end. And in the end, again, if you say gravity is an electric force and it uses a field, then you're going to get the question of the average person who's going to go, what's the field? And how does that work? So these are very good questions at a basic level. So I did see another hand up. Okay, I'm going to add Dennis. Go ahead.
Morton Spears has electrostatic capacitance theory of gravity, but he died before he could completely finish up. So his daughter published posthumously his paper in Galilean electrodynamics.
Right.
And it caught my eye. I subscribed to that. So I realized that he needed someone to finish it up for him. So I tried to do that. I wrote a book, Foundation of Neo-Spiritual Gravitational Theory with Application to Earthquake Early Warning Systems. And
so it's another electrical, gravity's an electric phenomenon?
capacitance. You can treat protons and electrons as spherical capacitors if at a distance, no matter what they actually are close up.
So it's a field. There's a field there again. I hate to interrupt, but there's a field there, right? Because I know you're doing it at a distance. Because
it's more of a potential theory than a field theory. But
I
potentials and fields are closely related.
But what's the physicality of the potential of the movement then? What is actually making those things move together other than just a potential? Is it you're saying electrostatic? Is it electric field? What is, I know what you're saying.
It's the electric field, but it's a little complicated. Let me explain.
Well, we don't have I mean, I understand if it's a complicated thing. We're just trying to get some general comments on these.
Is that the proton-electron mass ratio is over 1800, and that's what makes this whole theory go. It's the only theory I know of that relies heavily on the anomalous, as it's called, proton-electron mass ratio, and just uses Coulomb's law, the speed of light, E equals mc squared, and this useful fact about capacitors and capacitors.
I understand. Okay. So you're saying that okay, it's like on Coulomb's law, and of course Coulomb's law is charge, and the question obviously then becomes what is the force in Coulomb's law? How that's really happening? But okay, I got you, and I appreciate the comments. Again, if we got into everybody explaining everything about the theory, it would be tough. But again, what that seems to be based on the actual force, because if you're a person's walking along the sidewalk who loves science, right, and you're talking about this theory, and it's based on, for instance, like you were saying, Dennis, between the difference between the proton and the electron mass of 1800 times, and that it's based on Coulomb's law because you believe there's charge and the charge has positive and negative. You still have the question on the person's going to say, well, that's nice, but what makes them come together other than just saying that there's a plus on one and a minus on the other, and there's a Coulomb's law, which is something we've come up with. It's really more of an empirical question. It's not telling us what Coulomb's law is. So again, I think in the more modern models, people are trying to, not only myself, but other people are trying to say, okay, it's wonderful to call Coulomb's law, but in the end, you can't have magical forces at distances because there's some, force there that we talk about, but we want to look into it. So again, I'm not saying this idea is wrong. I'm not saying that this idea is not the explanation for gravity. I'm saying that we're still sort of talking about things that in the end will not tell us what the actual force of the push or the bringing together of those objects other than they are an empirical formula. So the question is can we always come back to a question of what is the physicality of what's happening there? Okay, somebody else in the green room who wants to talk about gravity, and I know you had your hand up, Franklin. Did you want to talk? Yes? Okay. Hey, Franklin, and thanks for helping me out with the volume, the feedback.
Yeah, we've just been chatting, so I was going to summarize a little bit about what we were talking about. So I guess we were talking more about, say, an electrical type explanation for gravity kind of thing. Now as far as this ether is concerned, unlike Shaw's theory where the ether is actually doing the pushing, I'm an etherist, and the way gravity works in my theory is that the ether simply acts as a medium of transmission for the energy. So it's just like the ether also acts as the carrier of light waves, the permanent light waves, and so the gravity is just transmitted through the ether. So that's how gravity and the ether are related in, say, Why ether
Is that different from light? Because is because
Well, that's
light
the
light
interesting
is yeah. Go
That's
ahead.
the
Go ahead.
interesting thing about my theory, because I
Okay.
think that gravity is actually fundamentally a light form of light wave.
Mhm.
Because I think gravity is actually just an electric force. I mean, it's as simple as the Earth being positively charged. That's it. We're sitting on a positively charged ball, and all neutral matter is attracted to any point charge, and that's it. I mean, that's how complicated it might
But
go.
okay, but I'm a little confused now because we have a ether theory, which is not electric. It's really more about the collision and waves being transmitted through a more stationary
Yes, I mean, at some
particles.
point we were
But
discussing
but
that.
now you're talking something on top of that. I got lost there. How did you get from ether gravity being and I understand the idea of transmission through the collisions, right, which is light, and you say gravity, but now you're all of a sudden talking about the charge. Now, is there a different medium for fields, electric fields?
No, actually not. In my theory, it's the same medium for everything: magnetism, charge, gravity. They actually all turn out to be just the electric force. So that's the unification that people are seeking, right? You want to unify everything down into one thing. And so everything turns out to be an electric force. So gravity is an electric force, magnetism is an electric force.
What's your definition of electric?
Electric is the forces between the positive and negative things. So between the electron, because we see the spontaneous attraction of these two things. So
okay, but I'm confused again because I'm not trying to argue. I'm just trying to understand. So you said that the medium of collisions does everything and all the different forces. Then all of a sudden you're putting pluses and minuses on again. I'm lost. I'm lost
and
there.
I'm trying to explain in the chat that I think that the difference between the pluses and minuses is actually just a difference in phase. So positive charge goes, this way, and negative charge goes the opposite way, like that. So we're getting back to explaining what the charge is in terms of phases. So I'm not sure. So this is the trick. You cannot explain charge in terms of charge. You just can't say that opposites attract, right? You just can't say that. You have to explain it in some other way. So otherwise it's cheating. It's totally circular, right? So I'm saying what charge is just a difference in phase. So they're just going in opposite phases. That's
okay.
what I say. So if you have them going in the same phase, they generate waves which add, creating a higher pressure, and that's just a higher pressure of like a gas, like a vacuum cleaner. If you take a vacuum cleaner, you put it next to a ping pong ball. The ping pong ball is not actually being sucked to the vacuum cleaner; it's actually being pushed.
No, yeah, I understand. That's I guess the part that gets confusing in when you're describing your model, and I'm not disputing it. I'm not saying it's wrong or right. Is when you talk about pluses and minuses or charges or fields and electric, and you've got ether. It gets confusing to me listening to it. The model starts blowing up in my head, and I'm trying to figure out, okay, well, wait a minute, everything's transmitted through ether, then we should be able to talk about transmitted through ether if everything's explainable by that. But then you talk about pluses and minuses and charge and everything's electric, and I said, how can ether be electric? I get sort of lost in the vocabulary.
To the ankle, to the elbow, to the arm. And so I'll just explain that you start with an ether. I build it out of positrons, electrons. It doesn't really matter. Could have been anything. But so you build it out, but I prefer to pick something we actually know. So you've got this space. It's filled with that. That can carry waves, right? We can understand. You push it, and it's like wave goes. It's just collisions, right?
Mm-hmm.
And then you have something, you put some other particle in space. We call that an electron. And what you do is that it's like a bell. You hit it, it rings. It goes ding. We call that an electron. You put another particle in space. We call that a positron. It's also a bell. You hit it, bing, it rings. But it rings 180 degrees out of phase. I mean, it sounds the same to you, looks the same, the bells look the same, but
there's no explanation. You don't have an explanation why these things would ring in as an electron versus a proton. Why does that happen?
The only explanation I have is I believe that time and space are ultimately quantized. That somehow there is some master clock And so if you have something, the smallest possible particle, it can only take 2 states. This is why it gets down to the digital basis of what reality might be. People talk about being a simulation. Well, this is kind of evidence that things break down to a binary state. So if you have a particle, it can only be in one of 2 states at any given time. Then when the computer of the universe was turned on, half of them just naturally random.
So there's the laws of the universe are somewhere stored somewhere that then tell these things how to work. So what you're saying?
Basically, I mean, you could do some experiment. Like I said, I think you could turn an electron into a positron if you just cool it down so that you stop the ringing, and then when you hit it again, it has the opportunity to become either a positron or an electron. So that might be an interesting experiment.
Okay. All right. I'm going to bring you down. Appreciate again, the idea here is to let people know about all the different ideas of people have on gravity and all those things. There's a discussion of something I knew would come up, which is the speed of gravity. You got a couple of things here people are talking about, which is electric force is instant as gravity is. Now, I don't know. I myself can't understand the concept of instant force because force to me is some type of an acceleration. I don't understand that. Another idea that no electricity is not instant, gravity is not instant. So that is something. Again, I have a problem even just logically trying to understand if anything can be instant. But again, if you have an explanation and can convince people, I can understand that. One of the things is I hear a lot of information. I know Nick Percival, who's not here today, he's going to be talking in a couple of weeks. He sent me an email about the Pushing Gravity book, which talks about the speed of gravity. And they talk about the speed of gravity being just a tremendously fast speed. Well, my dad and I, who have a model, we looked into real what we consider to be any type of information, of real information we could find on the real speed of gravity. Tom Van Flanders, who wrote the book Pushing, was one of the, I think he put the book together. It wasn't all his work, but put it together. He was saying that it was super fast. But when I read his book, it was a while back, I personally would question that what he was using to find out the speed of gravity was a legitimate way of looking at the speed of gravity. Just as trying to measure the speed of light, of a light ray going by you, a wave going by you, right now is an impossibility. We can't do that. I was a big skeptic myself of the way he was coming up with what he considered to be proof of the speed of gravity. Now, during a full eclipse, 2 things happen. You have light that comes to you from the sun. That takes about 8 minutes. And you also have gravitational anomalies that a lay measured. Some people say it's just the wind, but there are 2 Chinese scientists who we have that in our book as part of the reason we say gravity is the speed of light, that they measured gravitational force coming at the same time the light was coming from the eclipse, and those 2 both happened at the same time, both in entering the full eclipse and then exiting the full eclipse. And their conclusion that, in fact, gravity and light were traveling at the same speed. And that's what we assume. If you read a lot if you try to look at that, and mainstream science says that. Now, is that true? We don't know. All I'm just saying that's the closest thing that I could see that I would actually hang my hat on, my physics police hat on, and say, yeah, that's not a bad example of an actual because what you have is you have a gravitational anomaly is happening, when it's happening, and also light is being affected at the same time. So that was something. So this idea of instantaneous speed is something that could be a whole topic in itself. But anyways, we have 4 minutes left before we're done. If anybody in the green room wants to say any general comments, that would be great. I do plan on coming back and us talking. I know Ray's not here. Oh, Ray is, I think, still here. But I want to thank you, Ray. I'm going to bring you up again. I want to thank you very much for coming on. And actually, I just came up with this, I think, on Thursday or Wednesday, because I was waiting for Unziger to give me a thumbs up or thumbs down for today, and he couldn't make it today. So I said, well, we can talk about gravity. And then I got a lot of interest in that, and I got the information from you. And tell us, can everybody buy your book online? Is that on Amazon?
Yeah, it's $8.99. It just went up the other day.
Right.
Yeah,
I mean, this is a book hot off the presses, and it's cheap.
I did look into the electric universe explanation and find that plausible as well.
Right.
And that's the one that we didn't get to today. So
right, but we're going to come back.
I'm not advocating any one of these models.
So remember, Ray is saying that he believes all of the theories. No, I was kidding. No, I understand.
Can't reject any of them.
Right, exactly. That's the most important point. And so your book is available through Amazon. Anybody can buy it. It's $8.99, which is dirt cheap for that. It comes in a number of days. I want to congratulate you on your work. In fact, I think you got one of our awards at our conferences for your.
I was along with your dad, and was it Bill Lucas? There were three of us.
Well, yeah, there was the Lifetime Achievement, which went to Pollock, Gerald Pollock, for his work on the fourth phase of water. I think there were also helping out the organization. I think Franklin, got one, didn't he? For him working with the Saturday morning, and you did my father. So I appreciate your work. The organization appreciates very much your prolific award. I think it was. I mean, you had published more papers, I think, than anybody in our group in our proceedings. And if you haven't checked out Ray's work, take a look at it. And also, you're always on the lookout for other things to test, right? To look at the viability. Is that correct?
Yeah.
So now you're going to have everybody who has their own theory sending you. What I'm going to do is I'm going to make a business out of this for you, Ray. I'm going to take a percentage, and you're going to charge for your vibe, just like when you are building a home on some land, and Dr. Glenn Borkert, who's a geologist, gets paid like $350 an hour to find out whether you should build your house there. We'll have to charge per hour on whether or not your theory is actually viable. So I think you can make a business and retire again after this. So thank you so much, and you are willing to come back and look at the.
Let me know a few days ahead of time.
Yeah, well, it should be. Let's see, the 6th is next week, so it should be, I believe, after the 16th, so in like 3 weeks' time. So
Okay.
I will set that out, and I'll communicate with you. And thank you so much for your work. And if you haven't checked it out, look up Ray Gallucci, and there are lots of videos with him speaking. Probably at least 20 videos, right? That you have out there. So.
Well, I don't think there's that many. I don't know how many from the conferences.
There's quite a few.
So, but I've given 20 papers at the 5 conferences, and I've got 4 space.
So yeah, it's close to 20
on the electric universe.
Yeah, if you add up all those views, you could be a YouTube phenomenon, and not even know it.
I doubt it.
Okay, well, thank you so much, Ray. Thank you so much. Oops, I pulled him away too fast, but we do have to go. We're going to see Ray again. But I really do want to thank everybody, and I know a lot of people had a lot of comments. We plan to do more on gravity. And if you have of your own theory about how gravity works and can present it in a logical, sort of meaningful way, in sort of a scientific way, not just I think it's sort of like this, but sort of more of a formal way. We'd love to hear from you. We have this Saturday morning open for everybody. Normally, if a person makes a presentation, we make presentations anywhere from a half an hour to an hour, and they have a whole nother hour in discussing it. But I want to thank again everybody who supports this, and we're going to go get our way out here with a couple of Stinger videos before we wrap it up here. And like I always say, stay critical, stay thinking. I am David D. Hilster, your science therapist, trying to get you to the promised land of becoming a critical thinker. I'm not here to tell you about truth. I'm trying to get you there. Ciao for now.